Welcome to the lesson on Bohr diagrams for ionic compounds. Okay, so binary compounds means two atoms stuck together to form a compound. So we're going to focus on binary compounds, specifically ionic compounds today. When two atoms move close together, their valence electrons interact. A chemical bond forms between the two atoms which hold the atoms together. Atoms form chemical bonds in order to be more stable, i.e. have a full outer orbital, as discussed earlier. When atoms combine to form compounds, they gain or lose electrons. Metals lose electrons to nonmetals and form what are called cations. Nonmetals gain electrons from metals to form anions. Some atoms can share electrons, and we'll talk more about that later. So ionic compounds. An ionic compound contains a positively charged ion, usually a metal, and a negative ion, usually a nonmetal. In ionic bonding, one or more electrons are transferred from each atom of the metal to each atom of the nonmetal. Bohr diagrams for ionic compounds. So example 1, we're going to draw a Bohr diagram for a sodium chloride compound. Step 1, draw a Bohr diagram for one atom of each element in the compound. So we start by drawing a sodium atom and a chlorine atom. So when sodium comes near chlorine, what happens is this electron on sodium is very loosely held onto. And so it's not being held onto very tightly, and sodium wants to get rid of that electron. Chlorine, on the other hand, wants to have a full outer shell, and so it wants to gain one electron. So when sodium comes near chlorine, this electron will be transferred to chlorine, and sodium will become positively charged and chlorine will become negatively charged. As you learned in electricity in Science 9, opposite charges attract. So when they make that transfer and become charged, they stick together because of opposite charges. So step 2, transfer the valence electrons from the metal to the nonmetal so that they have a full outer orbital. Notice that sodium has one valence electron and chlorine needs one valence electron to have a full outer shell. Then draw brackets around each ion and write the overall charge. So we take this electron and drop it from sodium and we transfer it to chlorine. Then we draw brackets and write the charge, just like you did for ions in the last lesson. And that is the Bohr diagram for sodium chloride. Notice that there's exactly one sodium and one chlorine, so we say there's a ratio of 1 to 1. The chemical formula for sodium chloride then becomes NaCl. The imaginary 1 is not written there, but this means that there's one Na and one Cl, one sodium, one chlorine. Okay, example 2, we're going to draw a Bohr diagram for beryllium fluoride. So we start by drawing one atom of each, the Bohr diagram for the atom. Now notice here that beryllium has two valence electrons that it wants to get rid of, and fluorine only wants to gain one. Now that's a problem because beryllium wants to get rid of two, but fluorine's only going to be able to take one of them. So in this case, what do you think will happen? So in this case, we're going to add another fluorine atom and then transfer one electron from beryllium to each fluorine atom. So we're going to add a second fluorine atom. Now this one will take one, and this fluorine will take one, and beryllium will give away two. So So we erase it, draw it there, erase this one, draw it there, and then put brackets and the charge on each ion. Now notice here that there's 2 fluorines and 1 beryllium. So there's a ratio of 1 to 2, 1 metal to 2 nonmetals. So if we go back, the formula for this would be Be, which is a symbol for beryllium, and then F2 because there's 2 fluorines. Okay, now try drawing a Bohr diagram for beryllium oxide. You might want to pause the video here and just give this a try. Okay, so starting with beryllium, I'm going to draw the Bohr diagram for beryllium. So there's 2 and 2 electrons, and for oxygen there is a total of 8. So 1, 2, 3, 4, 5, 6, 7, 8. Now, beryllium is going to give away 2 electrons. It's going to give away 2. And oxygen needs to gain 2. 1 here and 1 here to have a full outer shell. So you don't have to draw any more beryllium or oxygen atoms. You're just going to take the 2 electrons from beryllium and transfer them to oxygen. So you have 2 electrons, and a charge of 2 plus, and then the oxygen atom, which is going to have 2 and 8. For a charge of 2 minus. The charges on the metal, the total charges on the metal must equal the total charges on the nonmetal in total. So if I had more than 1 metal, I would add up the charges on each one, and that would have to equal the charges on all of the nonmetals added together. And that concludes the presentation.